So just a little bit of background. Origin is trying to build decentralized marketplaces, connecting buyers with sellers, trying to cut out the middleman essentially, and using Ethereum and IPFS to basically using IPFS as the data layer and using Ethereum to kind of store those IPFS hashes, so that the idea being that the only two dependencies to run one of these stores are IPFS and Ethereum essentially. So you wouldn't need any other anything else in order to connect to one of these stores and purchase something. And so you can see that the site that I'm on right now, originswag.eth.link, that is this is an ENS domain. And I don't know if you're aware, but basically if you append .link onto the end of any ENS domain name, and it's pointing at an IPFS hash, then it's going to actually serve whatever is kind of at that IPFS hash just over the regular web, which is really convenient. But if I was to go to originswag.eth and just put a slash at the end of that, because I have the MetaMask extension, it's going to forward me directly to that IPFS hash here, and hopefully load up all of this stuff. So right now I'm using Pinata in order to kind of pin all of this stuff, and essentially what I've done is that this store is built, it's basically a static website. So all of the code for this is running in the client. So things like search, for example, if I was to type unicorn in here, this is actually a client-side search. So it's looked at all the titles of all the products, and because there's only 100 products or so, we're able to do that client-side. Obviously, if you're storing millions of products, then it might be a little bit more difficult. But the whole store here is working in the client side. It's all built with React.js. And so maybe I could just do a quick kind of demo of the purchase flow here. And I'm going to go ahead and buy an Origin sticker because it's only $2. So I can go ahead and add that to my cart. I can see that the cart up here is updated. I can look at my cart. I can modify the quantity. Subtotal down here is going to get updated. I can then go to the checkout, and this is going to load up the kind of Origin GraphQL package, which is the thing that basically connects to Ethereum and can query and make blockchain transactions here. So what I'm going to do is I'm just going to open up the network tab as well, so we can actually see kind of what's going on in here. Oh, that's a point actually. If I just go back to the main page again and just refresh this, then you can see that basically every single thing that's on this page is being loaded directly off IPFS.io. So that's including all of the images and media and all that stuff. And if I actually have a look at this URL here, this is actually where all the data is stored here. So I can actually see what the kind of database looks like, if you will. Is essentially all of the different products live in these different directories. So if I was to have a look in here, I can see that we have a data.json object, and that contains things like the title and description, price, all of the variants for the, if you want a small or a medium or a large, all of that stuff. So you have a data object, and then you have these directories that contain the images. So this is just, the different colors and sizes and things for all the different products there. So you have a subdirectory for each product, and then you have this products.json here, which is kind of is what we use for the actual listings. So we can see the title and all of the directory names here, and also what the kind of primary image is for that. So this is what's used to actually render the main index page here. And then we also have some other kind of metadata. For example, this shipping.json file contains the different shipping options. So we actually have free shipping for all of these. So the amount here is 0 for both international and domestic shipping. But if you had different shipping rates for different countries, for example, then you could put them into that shipping.json file. So that's kind of how we're using how the data is kind of structured and stored in IPFS. And essentially what we do is we kind of put all of it into a directory, including the, so actually maybe I can just show you what that looks like. So basically we're going to upload this whole public directory, and that contains all of the built JavaScript files, as well as this is this directory here, this origin directory that contains all of the database, and then we have all of the different the JavaScript files and all that stuff goes into this directory. So and then what we do is we upload this entire directory. So right now we're using Pinata to do that. So they have, I haven't actually looked into the Protocol Labs version. I'm not sure if you guys have a version of this. Would be happy to use it if you did. But essentially they have a directory upload thing. So we'll just upload that entire directory, and then it's going to give us the IPFS hash here. So if I go to that IPFS hash, it's going to give me that store. And then you can also see some other stores I've made here. So it turns out that the Ethereum Foundation use Shopify. And so basically what I did was I built a Shopify importer. So it's going to go and scrape the Shopify store for all of the product information and the images, and then put it into this kind of IPFS format so that it's very easy for someone who already has a shop to move over to this platform, the IPFS Ethereum platform here. So I did that for Ethereum, and I also did it for Gitcoin. Turns out that Gitcoin also have a Shopify store. So yeah, so that's the kind of process for building. That's what the database and the application code look like. So now if I just go back to the checkout process, let's just see if I still have that. Oh yeah, here we go. So I've got my cart with my sticker in it. I'm going to go to the checkout, and then I'm going to fill out my information here, just a fake address here. Got my shipping options here. And again, this is all hosted off using that same application logic. And then I have two options. I can either use a credit card, and this is obviously going to contact a centralized server if I want to use a credit card, but that credit card server can be run by any individual. It doesn't have to be, you don't have to rely on a given organization to run this credit card server. So I could run this myself. If you set up your own store, you could run your own credit card processing backend. So in that way, it's kind of maintains the decentralized piece where you don't have to rely on a company or organization to run your store. But for right now, we're going to use cryptocurrency. So I've got two options here. I can either pay with DAI or I can pay with ETH. So I'm just going to go ahead and pay with ETH for now. And if I just have a look at my network here, I can see what's actually happened. So I've got my MetaMask notification over here, but I just wanted to show you what's going on in IPFS. So right now we're using the origin IPFS server to actually pin this JSON file that we're uploading. And this is basically containing a PGP encrypted JSON object that contains my shipping information, my address, and my email address, because obviously I don't want that information to be posted publicly. So so basically I've encrypted it with via PGP, and this is using the public key of the seller. So in this case, it's using Origin's public PGP key, so that only Origin can decrypt this data, which obviously they need in order to fulfill the order. And what I've actually done is I've encrypted this twice. So the first one is so that it's readable by Origin, and then the second one, the same data is actually encrypted with a random string of basically a random password, and I'll get to that in a minute. But essentially, it's so that I can read my data if I want to come back and check on the status of my order. Then I've basically created myself a way to read that data. So, by the way, does anyone have any questions? Am I still online here?
Yeah, this is very
okay,
cool.
Great. So yeah, so the checkout information has been encrypted with PGP and pinned, and then the hash, the resulting hash of that is then put into another JSON object, and this is what's kind of used for, this is like an official Origin offer essentially. So this is another JSON object that has some data about you know, the offer that I'm making. So it's essentially the way that the Origin smart contract works is that, you know, if you're a buyer and you're buying something from someone with cryptocurrency, obviously there's no way for you to get that money back if the seller doesn't fulfill their obligations. If they, you know, if they have the money, then why would they bother sending you the product, right? If they wanted to, they wouldn't have to do that. So essentially the Origin smart contract works as a kind of escrow system. So essentially when you make an offer, what you're doing is you're sending the IPFS hash along with the payment, so that the IPFS hash kind of represents your order, and then you also send along the payment in either ETH or DAI or whatever other ERC20 token you have. You send that to the smart contract, and then those funds are then held in escrow until the seller kind of fulfills the order. So essentially there's a few steps. The buyer will make an offer, the seller will then accept that offer, and at that point they're kind of under contract, if you will. And then it's up to the seller to actually send the goods, and then the buyer will then finalize the offer. And by finalizing the offer, that will essentially release the funds to the seller. So the buyer is saying, you know, I got my goods, everything's okay. And then the buyer will then release the funds. Or there's also another mechanism, which is essentially there's a timeout window. So there's a window of time. You probably set it to maybe 2 weeks after the buyer is expected to receive delivery. And if the buyer still hasn't kind of finalized the offer by that 2-week period, then the seller can kind of take the money. So that just kind of protects from unresponsive buyers. And equally, if the seller is unresponsive, so if the seller does not accept the offer, the buyer can also withdraw their offer. So that just kind of protects against, you know, if you make an offer on something and then the seller doesn't respond because they lost their private key, or, you know, they just disappeared, the seller can get their money back. So the only other case is when, say, the seller doesn't get their goods and then the buyer says that they sent the goods, then either the buyer or the seller can initiate a dispute, in which case a third party arbitrator will kind of make a decision about who, you know, if the buyer should get a refund or not, essentially. And that arbitrator is picked. It's a mutually agreed arbitrator, so it doesn't have to be, again, like a particular individual or organization. That the buyer and seller kind of choose who that arbitrator is when the buyer is making the offer, essentially. So that's just a really quick rundown of how the smart contract works. So now let me go ahead and confirm this. So again, this offer consists of the IPFS hash. So if I actually look at the data here, well, this isn't that helpful, but essentially it's going to contain the IPFS hash of my offer that has all my details in it, and also the actual payment in ETH. So I'll go ahead and confirm that. And that is going to go ahead and mine that transaction on blockchain. And then what we have is in the back end here, this is that process this is the payment processor that I was telling you about, that the seller runs on there. So this is actually just an application that's being deployed to Heroku right now. And what this is doing is watching the blockchain for transactions that happen on my store, essentially. So as soon as this transaction gets mined, if it gets mined, I don't really know what's going on here. Yeah, it's pending, so I don't know how long this is going to take. This is like one of the drawbacks of using Ethereum, and sometimes I think it's like it can take a little bit of time. But essentially, this back-end process here is watching the blockchain for those events, those offer events, and you can see that it's seen the event now. And what it's done is it's downloaded that PGP data, so off the IPFS server. Because this backend process has the PGP private key, it's able to decrypt that information, which you can see here. So this is my email address and all that stuff. And then it's actually sent out a confirmation email. So if I go and check my email here, then you can see, because I'm both the buyer and the seller, I got all the different emails here. So this is the email that the seller would get, where someone placed an order on your store. You can have a look at the information there. And then as the buyer, this is the email that I get as a buyer. And if I actually go ahead and view that order, it's going to give me my confirmation screen here. It's got my order number, and this is like the number on the smart contract. And you can also see that up here is that, if you remember when I mentioned that we encrypted the PGP data twice. So this is the password for the kind of second blob of data. So this basically enables, so this is the transaction hash, the Ethereum transaction hash. So if I go to Etherscan and actually paste that in, then I can see that $2 worth of Ether was transferred, and I can look at the event logs here, and this here is the IPFS hash that contains the all of the offer data there. So yeah, and then this is the password that lets me decrypt so that I can actually view my name and address and all that. So if I actually like add 123 to the end of that, then it's not gonna work because that's an incorrect password now. And so yeah, that's basically a demonstration of of how all this stuff works. So I think that the cool thing about it is that it's only using IPFS and Ethereum, and also that the idea of this is that Origin is the idea of Origin is that you can think of it as like an open protocol. So anyone is able to add a store or a listing onto the Origin smart contracts, and then anyone else can make offers to those listings. And so whereas if you look at something like Shopify, for example, Shopify have an app store. Everyone who's building apps on top of Shopify is kind of beholden to Shopify. If you want to do something that Shopify don't like, then they can shut you down. They can they can ban you from the App Store. They have a lot of power, and they also have a lot of data. So you know, all of those transactions that are going through Shopify, like Shopify can see all of that data and you know, do whatever they want with it, essentially. Whereas if you build on an open platform where there are no dependencies, then you can be sure that your application is never going to break, and you don't need to worry about, you know, an organization or corporation taking control or denying you access or telling you what you can and can't do, what you can sell, what you can't sell. All of this code for this is open source, so you can go in and change anything you want. And I really think that that's the power of these kind of decentralized protocols, is that people are able to build tools on top of the protocol and have a guarantee that no one is going to come along and you know, change the rules or just say that they can't do it anymore. I don't know if you guys remember when Twitter originally had their API, and lots of people built tools on top of the Twitter API, and then Twitter decided that actually they were going to shut that API down, and all of those people were just kind of, you know, it was just tough luck, basically. So building on an open protocol like this, you don't have to worry about anyone telling you no. And so I think that's the difference between, you know, and the reason that I think that these open protocols are going to, you know, stand the test of time, hopefully. So yeah, I think that's pretty much it.